Welcome to the Explainer. Today, we are diving deep into one of the most fundamental, most important building blocks of Java, the method. So here's what's on the agenda. We're going to start with the basic anatomy of a method, then see how one name can actually do many different things. After that, we are going to settle a huge, classic Java debate. And finally, we'll look at some code to see it all in action. All right, let's get right into it. If you really want to get a handle on methods, you have to start with their core structure. So we're going to break down the 6 essential parts that make up pretty much any Java method declaration you'll ever see.
Okay, so believe it or not, every single Java method follows this exact blueprint. This comes straight from Oracle's own documentation. First up, you've got modifiers, things like public or private that control who can see and use it. Then you have the return type. What kind of data is this thing going to spit back out? After that, the method's name, of course, followed by a list of parameters it takes in. There's also an optional spot for any exceptions it might throw. And finally, the method body. This is the good stuff, the actual code that does all the work, all neatly wrapped up in those curly braces.
And all of that brings us to a really key idea, the method signature. You should think of this like a unique fingerprint for every method. It's made up of just 2 things, the method's name and the data types of its parameters. That's it. And this signature, this fingerprint, is exactly how Java tells different methods apart. You'll see why that's so important in just a second. Okay, so let's see how that unique signature lets Java do something really clever, letting one single method name handle a bunch of different tasks based on what you give it. This awesome feature is called method overloading, and it's a total game changer for writing clean, easy-to-read code. It means you can use one simple, consistent name, like, say, draw, for a whole family of similar actions, whether you're drawing some text, a number, or a complex shape. Check this out. This example from Baildung makes it crystal clear. See? We've got 2 methods, both called multiply. So how does Java know which one to use? Well, if you call multiply with 2 integers, the compiler is smart enough to match it to that first method. But if you pass in 2 doubles instead, boom, it knows to use the second one. It's all because of that unique method signature we were just talking about. Okay, so what happens if you call a method but the data you give it doesn't exactly match any of the signatures? Does Java just crash and burn? Nope. This is where it gets even smarter. It doesn't just give up, it tries to find the next best thing through something called type promotion. Here's how it works. Let's say you call a method and give it an int, but you don't have a version of that method that takes an int. If you do have one that takes a long, Java will automatically and safely promote your int up to a long just to make the call work. It basically widens the data type to find a match, and it follows these exact rules you see here. All right, buckle up. We are now heading into a topic that has confused Java developers, new and old, for years. Seriously, we're about to solve a genuine Java mystery. And here it is, the big question. Is Java pass by reference or pass by value? Getting this right is not just trivia, it is absolutely essential for understanding how data moves around in your programs. And trust me, it'll save you from some really nasty bugs down the line. So let's settle this debate once and for all. No more guessing. We're going straight to the official Java specification. And here's the answer, plain and simple. The Java spec says that everything, and I mean everything in Java, is pass by value. There is no pass by reference in Java, period. Now, for simple things like numbers, that's easy to grasp. You're just passing a copy. But the confusion, the whole debate, really kicks in when we start talking about objects. Yeah, the whole problem comes from that tricky word reference. See, in Java, when you have a variable that holds an object, it doesn't actually hold the object itself. It just holds a reference. Think of it as a pointer, a little piece of information that says where the real object is stored in memory. The best way to think about it is this. The object is the TV, and the reference is the remote control for that TV. Okay, if you remember one thing from this whole explainer, make it this. When you pass an object to a method, you're passing a copy of the value of the reference. You're passing a copy of the remote control. The method gets a duplicate remote. Now you have 2 remotes, but both of them point to the exact same TV. But hey, talk is cheap, right? Let's prove it. We're going to walk through 2 super simple code examples from a great Stack Overflow post that will make this crystal clear. Okay, scenario 1. We start by creating a dog object, and we'll name him Max. So we have our aDog variable, our original remote control, pointing to Max. Then we call the foo method and pass that remote in. Now, inside the method, it gets a copy of our remote. And what does it do? It tries to make its copy point to a totally new dog, Fifi. So what happens when we check the name of our original dog? The output is Max. It didn't change at all. And why not? Because inside that method, all we did was repoint the copied remote. Our original remote, a dog, never stopped pointing at our original dog, Max. It was completely ineffective. All right, now for scenario 2. We start the same way. Create a dog named Max, pass the remote to the foo method, but this time, look what the method does. It doesn't try to point its copied remote at a new dog. No, it uses its copy of the remote to actually change something about the dog it's already pointing to. It calls the setName method. And this time, Fifi. The name change actually worked. So what's the difference? Well, even though the method was using a copy of the remote, both the original remote and the copied remote were still pointing to the very same dog object in memory. So when the method used its remote to change the dog's name, it changed the one and only dog that exists. Okay, let's do a quick recap. We started with the 6 essential parts of any method. We saw how method overloading lets you use the same name for different jobs as long as the signatures are different. And we finally definitively settled the great debate. Java is always passed by value. And when it comes to objects, the value being passed is a copy of the reference. This means you can change the state of the object a reference points to, but you can never change the original reference variable itself. And that's our deep dive into Java methods. So I'll leave you with this to think about. Now that you know for sure that any method you call can change the state of an object you pass in, how does that change how you are going to design your code to be safer and more predictable? Something to chew on. Thanks for joining us.